Hey, welcome to The Explainer. Today, we're going to dive deep into the powerful, complex, and sometimes pretty wild engine that is the climate of the Indian subcontinent. It's a system that shapes the lives of over 1 billion people, and as you'll see, really understanding how it works is more important right now than ever before. I'm sure you've seen headlines just like this one. You hear about a region getting a third of its yearly rain in just one day. Or maybe another place gets hit with totally unseasonal hailstorms. Meteorologists themselves often seem baffled, saying that weather systems are just acting, well, peculiar. It really makes you wonder, doesn't it? Is something fundamental actually changing? And that right there is the million-dollar question we're tackling today. Is this just some random weird event, a blip on the radar, or is it a warning sign that the whole system, the climate itself, is starting to shift? To figure that out, we first have to know the difference. Okay, so here's the key difference, and it really comes down to time and scale. Weather is the right now. It's what you see when you look out the window. Sunny, rainy, windy, it's your daily forecast. But climate is the long game. It's the average pattern over 30 years or more. I love this analogy. Weather is your mood today, but climate is your personality. So if we're going to figure out if India's climate is really changing, we've got to pop the hood first, right? We need to see how this incredible engine actually works. And it turns out there are 4 main forces, or climatic controls, that dictate pretty much everything, from the scorching summers to those epic monsoons. Okay, so here they are, the 4 big players. Where India sits on the globe, its relationship with the huge oceans surrounding it, the height of its mountains and plateaus, and finally, these invisible rivers of air flowing way up high in the atmosphere. Let's break them down one by one. All right, first up, latitude. You can see the Tropic of Cancer cutting right across the middle of India. Everything south of that line is in the tropical zone because it's closer to the equator. That means it gets more direct sun, so temperatures are higher all year. The northern half, that's in the temperate zone, which is why it gets more defined seasons. Then we've got the relationship between land and water, which creates this kind of daily breathing pattern for any coastal area. During the day, the land heats up way faster than the ocean, so the cooler, denser air over the water rushes inland. That's your refreshing sea breeze. But at night, it flips. The land cools down super fast, but the ocean holds on to its heat, so the cooler air from the land gets pulled back out to sea. This constant back and forth has a massive effect on temperature. And wow, this slide shows you the real-world impact perfectly. Check out Delhi, way inland. Its temperature curve is a total roller coaster. Super hot summers, cold winters. Now look at Chennai, right on the coast. The curve is so much flatter. That's the ocean acting like a giant thermostat, soaking up heat in the summer and releasing it in the winter. So this incredible effect gives coastal areas what we call an equitable climate. Basically, the highs aren't quite as high and the lows aren't quite as low. That constant presence of the ocean just smooths out all those extreme temperature swings you'd see farther inland. Okay, number 3 on our list is altitude. And this one's pretty intuitive, The higher up you go, the colder it gets. It's the whole reason why even in the middle of summer, people flock to hill stations like Shimla up north or Ooty down south for a cool break from the blistering heat on the plains below. And finally, the last piece of the puzzle. It's a bit of an invisible force. Upper air circulation. We're talking about jet streams. Just imagine these super high-speed rivers of air flowing miles and miles above our heads. In winter, they can scream along at over 180 kilometers an hour. There's one particular jet stream over India that helps cool the air below it, and it plays a huge role in kicking off the rain. Okay, deep breath. Let's put all of this together. You've got a country split between 2 climate zones. You have this massive difference in how land and sea heat up and cool down. You've got some of the tallest mountains in the world. And you have these invisible rivers of air swirling above. You mix all 4 of those powerful ingredients together, and what do you get? You get the recipe for one of the most incredible weather events on the planet, the Great Indian Monsoon. So here's how the magic happens. In the summer, the huge landmass of India and the Tibetan Plateau just get absolutely baked by the sun. All that super hot air rises, and it creates this enormous zone of low pressure. Think of it like a giant heat-powered vacuum cleaner. And since nature can't stand a vacuum, this low-pressure area starts sucking in all the cooler, moisture-filled air from the high-pressure zones over the ocean. And its arrival, well, it's absolutely spectacular. It's called the onset of the monsoon, and this massive wave of moisture usually hits the southern coast around the 1st of June. From there, it just sweeps its way north across the entire country over the next month, bringing that rain that is both life-giving and sometimes incredibly destructive. This slide right here just nails the monsoon's biggest feature, the great reversal. Look at the left in winter. The cold, heavy air over the land creates high pressure, which pushes dry winds out to sea. But now look at the right in summer. That intense heat creates low pressure, which pulls all the wet winds in from the sea. This huge seasonal flip-flop of the winds, that is the definition of a monsoon. But the system doesn't just flip a switch and turn off. The withdrawal is a slow, gradual retreat. It starts in early September up in the northwest, and the monsoon slowly pulls all the way back. By December, the cycle's complete, and the subcontinent goes back to its dry winter pattern. Yeah, this transition period, it's not always a calm one. As the monsoon pulls back, you get this combination of still moist ground and high temperatures, creating this really oppressive, humid condition people call October heat. This is also prime time for those low-pressure systems to form over the Bay of Bengal, which can then spin up into destructive tropical cyclones that slam into the eastern coast. All right, so we've just taken a tour of this incredible climate machine. Now we've got to circle back to that big question from the beginning. What happens when you start messing with the basic energy balance of the entire planet? Okay, first things first, let's get something straight. The greenhouse effect is totally natural. In fact, it's essential. You can think of our atmosphere like a blanket that traps just enough of the sun's heat to keep our planet from becoming a frozen rock. Seriously, without it, life as we know it just wouldn't be here. So listen, the greenhouse effect itself is not the villain here. The real problem is the speed of the change. Since the Industrial Revolution, human activities have pumped just enormous amounts of extra greenhouse gases into the air. That's like making the blanket thicker and thicker, trapping more and more heat and causing the planet to warm up really fast. That is what scientists call anthropogenic global warming, or AGW. And as you can imagine, this has led to a pretty major disagreement on the global stage. Generally speaking, you have developed countries who industrialized a long time ago asking developing nations to cut their emissions. But the developing nations push back, arguing, hey, we need these fuels for our own economic growth, just like you did. And they say the wealthier countries should be the ones to lead the charge in developing and paying for cleaner alternatives. Now, while the politicians debate, the scientific community, well, they're pretty much on the same page. The overwhelming consensus is that human-caused global warming is real, it's happening right now, and it's driving these rapid, drastic changes in our climate system. And that threatens to make those freak weather headlines feel a lot less freaky and a lot more common. And that really brings us full circle, back to where we started. The monsoon is a system built on this incredibly delicate balance of heat and pressure. As we pump more and more energy into our global climate, we are fundamentally messing with that balance. This great rhythm has been around for thousands of years, but the question we're all facing now is no longer if this powerful, life-sustaining system will change, but how.